So in this video, what we're going to talk about is the reactivity of the anomeric carbon. So recall that we can have for instance, glucose, which is shown here. We can have it in one of two forms, either the linear form shown here on the right, or the pyranose form, which is the ring form for D-glucose. And so this is the beta anomer, and remember that the anomeric carbon results from the reaction of the alcohol, in this case, at the 1, 2, 3, 4, 5 position with the carbonyl carbon, in this case, what is an aldehyde. And so these are the anomeric carbons in both of these forms. Anomeric. Okay, now what happens when you react an alcohol with the carbonyl, such as an aldehyde or a ketone? So if we add ROH, an alcohol, where R is any group, but we can think of it as ethanol or methanol, so R can be a methyl or an ethyl group of some sort. So when we react ROH, it's going to react at the carbonyl. Think of it in linear form. Okay. So it's going to react, in other words, at the anomeric carbon. So this OH group, or excuse me, this OR group, is going to react across the hydroxyl, the anomeric carbon. So for instance, if we react with ROH with beta D-glucose, as we have written in the corner there, squeaky markers. All right, let's see if we can fix the marker. Okay. Jeez. Okay, try this one. There we go. Okay, down, up. Hydroxyl down, anomeric carbon. Hydroxyl's on the same side as the CH2OH over here. Okay, and now we have this, except because we have reacted with the alcohol, this is going to be OR, because it's reacted with the alcohol. All right, and so again, remember, this is our anomeric carbon here. And the result of the reaction of the alcohol group with the anomeric carbon is what's called a glycosidic bond. Bad luck with markers today. Let's try again. There we go. Glycosidic bond. And that is this bond between the anomeric carbon and the oxygen. And again, that's if we now have some sort of, for instance, instead of hydrogen, we have some sort of carbon group that's attached to this oxygen. We call this a glycosidic bond, okay? And so the difference here is that in this equilibrium, we can get back to the linear form pretty regularly. So while the equilibrium between glucose, D-glucose, so the pyranose form, and the linear form still lies strongly towards the ring, towards the pyranose. In this case, it lies even more strongly towards the ring. And so, in the sense that this is being able to convert back to the linear form from this, after this glycosidic bond has been made, is very difficult. It's very slow, and it rarely occurs then. So, because this equilibrium does not lie towards the linear, this pretty much stays in the pyranose form, and we don't form this aldehyde. Now, the consequence of that is that the aldehyde can react with a mild oxidant, such as copper 2. Form copper 1, and the oxidation of this aldehyde to carboxylic acid. And so you get what's called, let's see, I have it here, gluconic acid. So in this case, because D-glucose can react with copper 2 to reduce copper 2 to copper 1, we call this a reducing sugar. But in this form, in the form on the right-hand side here, where we have a glycosidic bond, and therefore, because of that, can't equilibrate very quickly to this, back to the aldehyde form, this will not react with copper 2 to form copper 1. And therefore, this is what we call a non-reducing sugar. So to summarize, when we react an alcohol with the anomeric carbon, we form what's called a glycosidic bond. We can also call the resulting sugar a glycoside. And so the glycoside is not a reducing sugar, again, because this oxygen is protected and the equilibrium doesn't lie. The equilibrium is not such that it's favorable to form any amount, anything but a negligible amount of the aldehyde. And since the aldehyde can't be formed, the aldehyde can't be used to reduce copper 2 to copper 1. So this is a non-reducing sugar. Whereas D-glucose, because the aldehyde form, or the linear or the aldehyde form is available within equilibrium, then this can interact with copper 2 to reduce it, and this is known as a reducing sugar. So the point is that formation of this glycoside, formation of this glycosidic bond changes this from a reducing sugar to a non-reducing sugar.